Right, we've got some functions to deal with here. Technically, this is also known as a function machine because you see the little bits in blocks as you're putting it through. We put a number k as the inputs, and then we find out that the output is also k, and we're asked to find the value of k. This is another way of saying what we've got a function here, what input maps to itself. We don't have to stress too much about that, but I was just going into the language. So if I put in k as the input, right, if I put 7 in, then when I minus 4, I'd get 3. If I put k in, I'm going to get k minus 4. And then I need to put it into the next bit. So again, if I had 7, I'd minus 4 to give me 3. And if I times it by 3, it would give me 9. So in this case, I'm going to get not 3 times 3, but 3 times k minus 4. Okay, that's the output. But I'm told that the output is also k, and so I'm actually creating an equation. 3 times k minus 4, that's the output. When I put k as the input, is also equal to k. And I've got to solve this now. I'm not going to divide through by 3, like I could in theory do that, but it's not going to go into k. So I'm going to expand the brackets instead. 3k minus 12 equals k. Then I'm going to minus k from both sides. 2k minus 12 equals 0. There's more than one way of doing this. Add 12 to both sides. 2k equals 12. Divide by 2. K equals 6. And that's the answer. And I can just check it. 6 minus 4 is 2. 2 times 3 is 6. Yep, that must be correct. No, you could have done this question by guessing some values, but this is a more rigorous approach. Okay, when I say rigorous, I also mean just a more robust method because, it happens to be a nice whole number, but you need to be able to deal with these sorts of questions if it became more complicated. Right, next part, the output of a function is y. We tend to call x the input and y the output. Write an algebraic expression in terms of y for the inputs of function a. This is another way of asking us for the inverse function, actually. Like what if I went the other way and had y as the input, what would I get as the output? But it doesn't matter too much. I'm just saying that's what the question's actually getting us to do. So if y is the output, I need to think, what do I multiply by 3 to give me y? And what we do is we do the opposite. We go the opposite way, and instead of timesing by 3, we're going to divide by 3, and we're going to get y over 3. And you can see if I times that by 3, I would get back to y. Now I need to think, what would I get? What do I need to minus 4 from to give me y over 3? And again, I do the opposite. I'm actually going to add 4, and I'm going to be left with y over 3 plus 4. And that's my answer. Y over 3 plus 4. Okay, you might get asked this another time and be asked to write down the inverse function, and then you would tend to write it back in terms of x. It would be x over 3 plus 4. That's the opposite function, the inverse function. But in this case, they've asked us to leave it in terms of y. Finally, we're given a composite function question. So that's when you apply the function and then you apply it again, or you might apply a different function. In this case, we're actually composing the function with itself. That's okay. Right, what's going to happen when I apply it to n, function a to n? Well, I saw what happened when I applied it to k. I got 3 times k minus 4. So when I apply function a here, I'm going to get 3 times n minus 4. And then I need to do it the same thing again, but this time instead of n being the input, I'm going to have 3 times n minus 4 as the input. Notice I'm not saying the brackets here, but the brackets are there as well. I think I'm going to take this one a bit more slowly. So if I put it into function a again, like imagine I put it in here, I'm first of all going to minus 4. So I'm going to get 3 n minus 4 minus 4. And then I'm going to times it all by 3. So I need to put a 3 on the outside and put another bracket here. And that's it. That will be my output. And basically what I've done is I've taken the same function as before, but I've replaced k by 3 bracket n minus 4 bracket. So yeah, this thing is my k from before. But I went a bit more slowly and actually applied the function from scratch. And now I need to set this equal to 96 and solve it. Well, you might be thinking, you know, that's 2 marks. Why did I even bother with this? But it's not that bad, and we need to be able to solve equations with brackets in and deal with this sort of situation. So let's do it. I'm going to cross that one out just so it's not confusing. Right, I've got brackets. I could expand all the brackets. There's nothing wrong with doing that and getting rid of them. Could expand this first bracket, but actually there's a bit of a quicker way. Because 3 goes into 96, what I can actually do is I can divide through by 3 to start with. So that's going to, I'll just get rid of this bracket essentially, and I'm going to have 3 times n minus 4 minus 4, and that's going to equal 32. What I can then do is I can add 4 to both sides. So that will give me 3 times n minus 4 equals 36. Okay, and now I'm in a similar situation again. I'm actually kind of in a similar situation to up here, but instead of timesing the bracket out this time, I'm going to divide through by 3 again, because 3 goes wholly into 36. So I'm going to be left with n minus 4 equals 12. And finally, I just add 4 to both sides, and that's going to leave me with n equals 16. And that is the answer. We can check if we want to. So let's imagine I put 16 into here. When I put it into function a, I'm going to minus 4 to give me 12. I'm going to times by 3. That will give me 36. If I then put it in again, I minus 4. That's going to give me 32. I times it by 3. And I do indeed get 96. So another little self-checking mechanism, so to check our answer.